All right, we know what a binomial is. A binomial is an expression that involves the sum or the difference of two unlike terms. So 3 plus 7x, for example. 5y plus 2b, all right? It's basically, or 5y minus 2b. Okay, it's the sum of two terms that are not similar, that can't be combined. Now, a lot of times what we have to do is when we have a binomial, we have to raise it to a certain power, right? You know, for example, that this is very common. A plus b, that's a binomial. And you know that we have to square stuff like this all the time, right? So this shows up constantly. Another one, you know, is if you have a binomial, lots of times we have to see that, you know, what the cube of that is, right? So you know that there is a shortcut or a formula for the a plus b squared. There's also a formula for, you know, a plus b cubed. But we sort of, like, we think these are, you know, just these random numbers that are put together. In actuality, there is a very, very clear, important pattern, right? So we know that if you have to square a plus b squared, right? What's the formula? It's a squared plus what? Plus 2ab plus b squared, right? And there is a similar one for a plus b cubed. Well, what if you had to do like a plus b to the power of 7, a plus b to the power of 11? Well, it turns out there is a very, very clear pattern that emerges here. All right, so let's just try a couple, okay? What is a plus b to the power of 0? What's anything to the power of 0? 1. What's a plus b to the 1? It's a plus b. What's a plus b squared? We just did that one. A squared plus 2ab plus b squared. Well, what about a plus b cubed? Well, it turns out it's a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, how do you know that? Usually it's in the back of some book. It's in the binomial chapter in Algebra 2. Your teacher tells you, you know, like they put it on the board and then, you know, oh, remember this? This is going to come in handy. But it turns out there is a cute little pattern here, right? Can anybody think about or come up with a pattern going down from a plus b to the 0 to a plus b cubed? Yeah.
The powers decrease and increase. So like for a plus b cubed, it goes 3, 2, 1.
Right? Right? Look at the a here. Look at the power of the a. It's a to the power of 3, a to the power of 2, a to the power of 1. What about here? A to the power of 0. And then b cubed, b, right? You have b to the power of 0, 1, 2, 3. Well, look, it's the same thing here. What's the exponent of a? 2, 1, 0. What about b? 0, 1, 2. At each step, though, if you add up all the exponents for each term, like what is the sum of the exponents here? 2. What about here? 2. What about here? 2. What are we raising it to? 2. What's the exponent here? 3. If you add them here, what's the exponent? And here? And here? And what are we raising it to? What about the coefficients? What about the coefficients? What's the first coefficient always? 1. What's the last coefficient always? What happens in the middle? So let's see the coefficients. Let's just write down the coefficients. Here you just have a 1.
They're the same number as the...
Well, let's see. We have a 1 here, right? That's all we have. We just have one number. What are the coefficients here? 1 and 1. What are the coefficients here? 1, 2, and 1. What are the coefficients here? 1, 3, 3, 1. Well, it turns out you can expand this. Oops, it turns out this is a pattern. Okay? Well, what is the pattern? Here's the pattern. Okay? If you write it more formally, this is what it looks like. The first one is always 1, a to the 0, b to the 0. The second one is 1, a, 1, b, right? The third one, the coefficients are 1, 2, 1, and look at the exponents, a squared, ab, b squared. All right? Well, what are we getting at? Look at this one. The coefficients are 1, 3, 3, 1. And what about here? 1, 4, 6, 4, 1. Do you see a pattern? Is there a pattern? What are the outside ones always? Ones. And the inside ones, believe it or not, there is, what shape is this looking like? A triangle. Well, guess what? Who came up with this triangle? Well, almost. So look at the pattern. Each expansion has n plus 1 terms. So look, here we're raising it to the power of 0. How many terms do we have? 1. So it's 0 plus 1. Right? 0 plus 1 terms. Here, what are we raising it to? 1. How many terms do I have? 2. Here I'm raising it to 2. How many terms do I have? 3. So you always have n plus 1 terms, right? Hang on. So look at the other one. The first and last terms are always a to the n and b to the n. So here, if this is to the power of 1, this is always a to the 1, b to the 1. If this is to the power of 4, this is always a to the 4, b to the 4. If you have something to the 5, you always start with a to the 5, end with b to the 5. The sum of the exponents is n. We already talked about this. You go to any term, look at this term. What is the sum of the exponents here? 4, and we're raising it to the power of 4. And the coefficients display a symmetric pattern, right? Look at this one. It's 1, 5, 10, 10, 5, 1. It's totally symmetric. 1, 4, 6, 4, 1. So if you fold this down the middle, all of the coefficients will match up with each other. All right? All right. So without further ado, Pascal is the guy who came up with all of this. Okay? This is Pascal's triangle. All right? The coefficients are called binomial coefficients, and they're in a triangular form. Here's the pattern. Each term is the sum of the two numbers right above it in the previous row. All right? So look, you have 1 and 1. They add together and give you 2. Now, in this one here, you have 1 and 2. You add them together, you get 3. You have 2 and 1. You add them together, you get 3. Here, 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. All right? So let's do this next one. What's the first number going to be? 1. Right? Well, now what do we get? You add these two and what do you get? 7. You add these two and you get? 21. Here?
35.
Here?
35.
Here?
21. 7.
And 1. Is it symmetric? Yes. Okay? That's how you get each and every single one. Am I going to give you the triangle? No. Can you come up with a triangle at any given time? Of course you can, because you put a 1 and then a 1, 1. And then it starts. The outer ones are 1s, and then you have a 2.
So the triangle is always the same.
It's the same triangle. There's one triangle. It's the same. Right? It's the same. Okay? So the first two rows are always 1 and then 1, 1. And then the outer ones are always going to be 1s, and the inner ones are going to be the sum of the ones prior. So here we have 2. And what is this going to be? You have a 1 and a 1. Inside you have 3 and 3. How many terms do you have? You have 1 term, 2 terms, 3, 4. So with each step, you add 1 more number, right? How many terms do you have here? 1. How many in the second row? 2. How many in the third row? 3. And then 4, and then 5, and then 6, and then 7. Okay? The only thing you have to be careful of is this is called step 0. And this is step 1. It's just, it is what it is. Because we start with n equals 0, and then n equals 1, and then n equals 2, and n equals 3, and so on. So let's move on down further. So, all right, so here it says use Pascal's triangle to expand each binomial. Now, I want a plus b to the 6. So I want the step for n equals 6. Remember, I'm going to start with n equals 0. So let's just write down the triangle. What's the first row? 1. What's the second row? All right, so now this is row 0. This is n equals 1. And what about n equals 2? It's going to be 1, 2, 1. What about n equals 3? What about n equals 4? You tell me. Right? So what is this now? N equals 3, n equals 4. We got to go 2 more, right? 1. Tell me. 5, 10, 5. 10, 5, 1. This is n equals 5. And finally, we got 1, then 6. Tell me.
15, 20, 15, 6.
And 1. Okay? It's got to be symmetric. All right, so now we've got n equals 6. All right, now we have to expand this one. So these are going to be the coefficients. How many how many terms do we have? Ooh, look at that. How many terms are we going to have? 7. Why is it 7? Because it's always n plus 1. Yes? So, come on. All right, so here's how I do this. Oh my God, come on, what the heck is going on today? There's always a new surprise when we come back. All right, so we're going to have 7 terms. All right, so here's what we do. You write down the coefficients and leave a little space. Is this still recording? It says it is. 7th row? Right, because we start with n equals 0. Okay, so now we write down our coefficients and leave a little space. So it's 1, 6. 1, 6, 15, 20, 15, 6, and 1. Okay? Now we're going to put in our A and our B. So the way it starts is this first term here, you start with that to the power of 6. Okay? And the other one, you start with that to the power of 0. So let's do the A's first. All right, so it's going to be A to the 6, A to the 5, A to the 4, A to the 3, A to the 2, A to the 1, A to the 0. And the B's, you're going to start in the opposite order. No. I'm just doing it just to demonstrate, but I'm not ever again. All right, so the B's, it'll be B to the 0, B to the 1, B to the 2, B to the 3, B to the 4, B to the 5, B to the 6. At any given time, if you add up the exponents, they must equal 6. Okay? And in the middle, you've got your pluses. Okay, so now finally, you don't have to write the 1. So this is just A to the 6 plus 6 A to the 5th plus 15 A to the 4 plus 2, oh, sorry. sorry, 6a to the 5b plus 15 a to the 4b squared plus 20 a cubed b cubed plus 15 a squared b to the 4, 6ab to the 5 plus, that was a b to the 6. Okay? That's your answer. So we've expanded. You could either have done a plus b, a plus b, a plus b, a plus c 6 times, or you could just do that. Okay? All right, so let's do this one. Now, in this case, what is your first term here? What is the first term? It's 3x, and the second term is 2. All right? Now, here I have n to the n equals 5, so it's going to be this term, right? So it's going to be 1, 5, 10, 5, 1. I write down my coefficients, 1, 5, 10, 5, 1. Okay? Pluses. Now, I start with the first term. It's going to be 3x to the power of what first? 5. In parentheses, please, 3x to the 5, 3x to the 4, 3x cubed, what did I miss? Oh, I missed the 10. Yeah. All right, so we have, all right, so that's how you can catch yourself too, right? I should have 6 terms. 1, 2, 3, 4, 5, 6. Now I got them all. So 3x squared, 3x to the 1, and 3x to the 0. You don't even have to write that one. It's always this exponent plus 1. And now, what about the other one? Now we're going to start from 0, right? So 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4, 2 to the 5. And now you have to do the math, all right? Here, who does this exponent of 5 belong to? The 3 or the x or both? Both, right? So it's going to be 3 to the 5, which is what? 3 to the 5. All right, so 243, x to the 5th, plus, now here I have 5 times 3 to the 4, which is how much? 81. Times 2, okay? X to the 4, plus 10 times 27 times 4, x cubed, plus 10 times 9 times 8, x squared, plus 5 times 3 times 16, x, plus, how much do we get here? For the last one, just a 32, okay? Now, I'm doing it in this detail the first time, but I won't do it in that much detail each and every single time, okay? Because at this point, this is now, you know, more arithmetic than pre-calc. Which one? Did I? Where? The x's are always in the end, right? You always write the coefficient first, then the variable. So what do we have here? We have 243 x to the 5th plus 810 x to the 4 plus, what's 40 times 27? 1080 x cubed plus 720 x squared plus 240 x plus 32. Okay, so that's your answer there. All right, now, in this term, remember, this is always a sum of two binomials. Your first term is x. What's your second term? Negative 2y. All right, the second term is negative 2y. All right, so that's how we're going to do it. Now, how many terms is this one going to have? How many terms? 7. All right, and it's going to be the n equals 6 step. So what are our coefficients going to be? It's going to be 1, 6, right? Right, so 1, 6, 15, so that one. So let's write that down. 1, 6, 15, 20, and then 15, 6, and then 1. All right, now we're going to square them, right? I mean, we're going to raise them to their exponents. So it's going to be x to the power of 6, x to the power of 5, 4, 3, 2, 1, 0. All right, and now the next one, it's going to be negative 2y to the 0, negative 2y to the 1, 2, 3, 4, 5, 6. Okay? So let's start with the coefficients here. Let's see what we're going to get. Well, the first one is just x to the 6, right? The second one, is it going to be a positive or a negative term? Negative 2y to the 1, it's going to be a negative 12, x to the 5, y. What about the next one, positive or negative? Negative 2y squared, is it positive or negative? Positive. It's 2 squared is 4 times 15. X to the 4, y squared. The next one is negative, right? And we have 20 times 8. X cubed, y cubed. The next one is positive. 15 times 2 to the 4 is 16. X squared, y to the 4th. Minus now, 6 times 2 to the 5th is 32. X, y to the 5. And then finally plus 64, y to the 6. So simplifying the coefficients, I got x to the 6 minus 12 x to the 5y plus 60 x to the 4y squared minus 160 x cubed y cubed plus 240 x squared y to the 4 minus 6 times 32, 192 x y to the 5th, 64 y to the 6th. Okay, so if the binomial has a plus, if it's x plus 2 to the y, they're all pluses. But if you've got a minus, what happens to the sign? What happens to the sign? It has to alternate. Okay, so the sign has to alternate, plus, minus, plus, minus, plus, minus, plus, minus. Okay, always, always, always. All right. So I'm going to modify the homework for tomorrow. I want you to do 1, 5, 9, just like it says here. And I also want you to do 11 and 13. And for all of them, ignore the instructions. I just want you to do expansion using Pascal's triangle. So just like what we did today. Okay? And you have to be able to write down Pascal's triangle at any given moment. Like on the test or on the homework, draw it one time so you can always refer to it and label it as, you know, n equals 0 to n equals 6 or whatever, so you always know.
You only have to do it once.
You only have to write it once so you can refer to it time and time again. Now, tomorrow, I'm going to teach the second half of this lesson, and you need your graphing calculators for that. And I'll show you another way to do this, but for the test, you have to be equally knowledgeable in both, because I'm going to test both, okay? All right, let's review a bit.